Hi, good evening, everyone. Am I audible?
Ma'am, you're audible, ma'am.
Okay. So this is your week 10 open session. Yeah, my screen is visible now.
Yes, ma'am.
Okay. So in week 9 also you studied some things about random variable. So in this week we have to study about the expectation and variance of a random variable. Okay. So first of all, tell me what is a random variable? Anyone? What is a random variable?
Random variable is a numerical outcome of a random experiment.
And what is a random experiment?
An experiment which produces a random result from a fixed set of outcome.
Okay, yeah. So a random experiment is an experiment whose outcomes we already know, but what exact outcome you will be getting, that we don't know, right? Okay. So the sample space we know, but what exact outcome will be we will get is unknown to us, right? Suppose you are throwing a die, so you will be getting number from 1 to 6. We already know, okay? But what exact number we will be getting, that we don't know, right? And two types of variable we have studied, right? Continuous and discrete, right? Hello.
Yes, ma'am.
Okay, so there are two types of variables, right?
Yes,
Continuous and
ma'am.
discrete. And what is the difference between these two?
Ma'am, discrete are countable quantities.
And
Continuous,
continuous.
we cannot count them.
So what we do with continuous, if we cannot count them, then what?
Make interval.
So
Measure its measure.
Can be represented in decimals.
it's not about decimal, we can say, because discrete variable can also be decimal. Okay, like discrete variables are variables that can take distinct values on a real line. It can be in decimal also. Okay,
Continuous
most of,
limits
but
represent
most of
measure.
the, yeah, continuous variable are variables which takes values in an interval, so they can take any value in this interval, right? So generally we see that discrete variables takes integer value, but it is not the case. They can take decimal values also, but most of the time in practical example, if you see, so in that case they will be taking most of the time integer values only. Okay, so discrete example of discrete and continuous.
Students,
The
Or
discrete
discrete number of
mark
people in a group.
Number
number
of,
of students discrete average mark continuous.
okay, so number of students in a class, okay, number of
Yeah.
balls in a box, so that are discrete, and continuous like height or weight of a person, right?
Yes, ma'am.
So next we study about the probability mass function, right? And probability mass function is for which kind of variable? Like for discrete or continuous?
Discrete.
For discrete, right? So we study probability mass function. And how we represent them. Like suppose x is a variable, okay, and which takes some values, okay. So how can we represent a probability mass function? Okay, so we represent them in like in this way. Okay, suppose it is taking values 1, 2, 3, something, okay, and there then we represent the corresponding probabilities, right? So in this way, in this form, we represent the probability mass function, right?
Yes,
Yeah.
ma'am.
Okay. Now the first thing that we have to study about the random variable is expectation. Okay. So anyone knows the formula for expectation?
Value of random variable and multiplied by probability at that point.
Yeah. So suppose we have a random variable x, okay, and suppose it is taking values x1, x2 up to so on, okay. So the expectation term is defined as the summation of the values that it is taking and the corresponding probabilities, okay, over the range of x, right? Okay, so this is the formula for expectation of a random variable. Okay, now let's take a few examples and calculate the expectation for them. Okay, so a very simple example that rolling a die for one time. Okay, so rolling a die once. So what will be the probability? Okay, first of all, what will be the sample space?
Numbers 1 to 6.
Numbers 1 to 6, right? Okay, so suppose we are taking a random variable which represents the outcome of the experiment, okay, or outcome of the roll. Then what values x will be taking here?
1, 2, 3, 4, 5, 6.
Yeah, so 1, 2, 3, 4, and 5 and 6, okay.
Mm.
And what will be the probabilities?
1 by 6 for each.
Yeah, 1 by 6 for each. Any doubt in this?
No.
Okay, now we have to calculate the expectation. Okay, so we just simply have to use this formula. Okay, so expectation of x, so it will be x multiplied by the corresponding probabilities. Okay, so 1 with probability 1 by 6, right? Then it is taking value 2 with probability 1 by 6, then 3 with 1 by 6 probability, then 4 with 1 by 6 probability. Okay, similarly for 5 and 6 also. Okay, so what will be the value calculated?
21 by 6.
In decimal?
0.5.
Hmm?
3.5.
3.5. Okay, so this will be the expected value of this experiment. Okay, now what this expected value tells us? Any guesses?
In multiple throws, this will be the average, like average of all the throws. Like if I throw it 100 times and
Hmm.
sum up all the outcome and divide it by 100, this is
Hmm.
more likely to be the result. 3.5.
Yeah. So expected value tells us that if you are doing the same experiment for a large number of times, okay. So in this example, suppose you are rolling a die, suppose 100 times or 1,000 number of times, okay. Then you will be getting some outcomes, right? Then the average of the outcomes will be this, okay. So this does not tell you that you will be getting an like getting an outcome of 3.5, but it tells you that the mean of all the outcomes will be 3.5, right? Okay, so we can write that we would expect the average of a large number of trials, large number of rows, you can say, to be 3.5, right? Okay. Now let's take another example. So, okay, so rolling of die 2 times. Okay, now I'm taking a random variable as sum of the outcomes. Okay, so what values x will be taking?
2 to 12. Single die or okay. 2
Okay, so
times.
we are,
Okay. 2 to 12.
yeah.
2 to 12.
Okay, so it will be from 2 to 12. Okay, so first of all, we will write the probability mass function and then we will find the expectation. Okay, so it will be 2, 3, 4, 5, 6 up to 12, right? And what will be the corresponding probabilities? Okay, so what we have to do, you have to make the sample space first if you don't know how we do this thing. Okay, so sample space would be like this: 1, 1, 1, 2, okay, up to 1, 6, and 2, 1, 2, 2, like this. Okay, up to 6, 1 up to 6, 6, right? So this will be the sample space of our experiment. Okay, now you have to see for what outcomes gives you the sum 2, what gives you sum 3, and what gives you for sum 4. Okay, so if you see, only this outcome will give you the sum 2, right?
Yes, ma'am.
So the corresponding probability will be 1 divided by 36 because total 36 outcomes are there, right?
Yes, ma'am.
So it will be 1 by 36. Now for 3,
2 by 36.
2 by 36. Okay. So 1, 2 and 2, 1 will be giving the sum 3. Okay. So it will be 2 by 36. Okay. So you can calculate the probabilities for all the outcomes, right? So for 4, it will be 3 by 36. Okay. Then 4 by 36. Then 5 by 36. 6 by
6 by
36.
36. 5 by 36. 4 by 36. 3 by 36.
Okay. So this will be a probability mass function for this experiment. Okay. Now we have to calculate, we have to find the expectation. Okay. So what we have to do, we have to multiply the value of x with their corresponding probabilities, and we have to take sum of all these values. Okay. So it will be 2 into 1 by 36 plus 3 into 2 by 36, right? Then 4 divided by 4 into 3 by 36, right? Now calculate this expectation. What will be the answer?
Thirty-six divided by 36. No, sorry.
Madam, explain once again, madam. Udaya.
How we find expectation, right? So what we have to do, we find an expectation value for a random variable, right? Expectation of a random variable x. Okay. So if you have a random variable, it will be taking some values, right? Suppose your random variable is x. Okay. So it will take some values. Okay. Which in our case are 2 to 12. So do you understand this thing? Is it clear? Like how
Yes,
random variable x is taking values 2, 3, 4, 5, 6 up to 12? Okay.
Yes.
Okay, and you have a random variable, it is taking uh, some value. Okay, so some probability will also be attached to that values, right?
Yes, ma'am.
So what you have to do, the formula is this. So you have to multiply the values that it is taking with the corresponding probabilities. Okay. And you have to take sum over this. Sum over all the values that x is taking here. Okay. So x multiplied by the corresponding probability and their sum. Okay. So in this example, you can see that value x is taking 2. Okay. So 2 into the corresponding probability, which is 1 by 36. Okay. Then 3 into 2 by 36, right? Then 4 into 3 by 36. Then 5 into 4 by 36, right? So in this way, you have to calculate the expected value. Okay. Now calculate it and tell me the answer.
182 by 36.
Can you convert it into an integer? Like, or like
5.05.
okay, please check it again. I think this should not be the answer.
Okay.
Ma'am, is it around 7.5?
I think it should be 7.
It's 68 by 9. I mean 272 by 36.
I think it will come around 7. Should be 7. Okay. Have you solved it?
Yes, ma'am.
Ma'am, it is
It's
coming 9 to 1.
no, ma'am. It's 6.72.
Okay,
Ma'am,
whatever
it's
the
come,
values are
ma'am, it's
taken,
come 7, ma'am.
it will be 7.
Ma'am, exact 7.
Okay, so it will be 7. Okay.
7.
So the expected value is 7. Now tell me, what can you interpret if the expected value is 7? So what does it tell you about this random variable, about the experiment that we are doing here? Okay, so the experiment is that we are rolling the die 2 times. Okay, and we are taking the random variable is the sum of the outcomes on the 2 dice. Okay, so here the expected value came to be 7. So what does it tell you?
This means that for a long run, the average of the sum of outcomes
Hmm.
will be nearly 7, like very expected to be 7.
Correct. Okay.
Ma'am, one question. So this says long run, but how long? Like, is there any limit that at least this number of attempt we should make to expect this value?
See, like limit is not there, but you can see that if you perform your experiment, suppose say 100 times or
Hmm.
times, okay, or 500 times, or like you can like any number of times, okay, then you
Hmm.
can see that the expectation will come around 7.
Yeah. But like lesser the number of experiment will like higher the number of experiment, this expectation will be likely to be correct.
Yeah, you can
So.
say that, but yeah, but there is no limit, like you have to perform it at least 100 times, no foundation like that. But
Hmm.
yeah, longer the experiment, accurate the result will be.
Okay.
Okay, so suppose you are doing the experiment a large number of times. Okay, so you can assume that uh, the mean of sum of the two outcomes will be approximately 7. Okay, it's not always that it is always equal to 7, but approximately equal to 7. Okay.
Yes,
Like it
ma'am,
can be
yeah.
6.9 also.
Likely to be
Like,
7.
yeah, likely to be 7. Okay. And if you have to make the like graph of your PMF, how can you make this?
You have
Okay.
to plot
So,
the values
so
taken
on
by X
x-axis,
on
you will be
x-axis
plotting the values. Okay. So here it
and
is from 2 to 12. Okay.
12.
Like 2, 3, 4, 5, 6, 7. Okay. And the corresponding probabilities you have to plot it on the y-axis. Okay. So for 2, the value is 1 by 36. Okay. Suppose this is 1 by 36. Okay. Suppose this is 2 by 36. Okay. So this is 1 by 36. Then for 3, it is 2 by 36, right? Then it is 3 by 36, right? So it is increasing. Okay. So up to 7, it is 6 by 36. So suppose it is like this. Okay. So before 7, it is increasing. Then after 7, it is again decreasing, right? So this is just a rough figure for the PMF. Okay. Now is it clear how we make the graph for PMF?
Yes, ma'am.
Okay. Now similarly, you can take example of a coin also. So like tossing a coin for 3 times. So what will be the sample space? So it will be head, head, head. Okay. Then head, head, tail. Okay. Then head, tail, head, right? Then tail, head, head. Okay. Next. This should be your random sample space, right?
Yes, ma'am.
Okay. Is it correct or not? This is correct, right? Now
Yes.
suppose you are taking a random variable which represents the number of heads. Okay. Now what will be the values for it? Number of heads in this experiment. So it should be 0, 1, 2, or 3. Okay. So the number of head minimum it could be 0, right? Like for this outcome, because there is no head, right? So it will be 0, or it will be 1 head. Okay, which is the case for this, and this also. Sorry, number of heads, not this one. So number of heads should be equal to 1 or 2, or maximum it could be 3, right? Because we are tossing the coin maximum 3 times. Okay. So this should be your values, right? Is it correct or not?
Yes, ma'am.
Okay.
Yes, ma'am.
Now you
Yes,
have
ma'am.
to find out the corresponding probabilities. Okay. So see what are the favorable outcomes for these numbers. So when x is like 0, which means the number of heads is 0. So number of heads is 0 in this case, right?
1 by 8.
Okay. So it will be 1 by 8. Okay. Then number of heads should be 1. So what are the outcomes? Favorable outcome for this?
Okay.
So this one and this one, right? So it should be
Yes, ma'am.
3 by 8. Okay. And for number of heads equals to 2,
3 by
it
8.
would 3 by 8. Okay. And number of heads should be equal to 1. So this one only.
1 by
So it will be 1 by 8. Okay. Now, if you want to check whether it is a valid PMF or not, how will you check that it is a PMF or not? So what are the two conditions for PMF?
They all should be less than 1 and their sum is equal to 1.
So the properties are like that the probabilities should be greater than or equal to 0, right? And the sum of the probabilities, okay, that should be equal to 1. So you can check. So whether 1 by 8 plus 3 by 8 plus 3 by 8 plus 1 by 8, it should be equal to 1, right? Okay. And all these
Yes, ma'am.
probabilities are greater than or equal to 0. Okay. All are positive here. So it will be a valid PMF, right? Any doubt till this point?
No, ma'am.
No?
No, ma'am.
Now we have
No,
to
ma'am.
find the expectation. Okay.
But ma'am, I have a doubt in one concept.
Hmm.
So so there is a question that area under the curve of cumulative distributive function is 1, and that option was wrong in a 9.6 activity question. So can you explain that one?
Okay. So let's finish this part. Okay. Then we will see that also. Okay. In week 9, right?
Yes, ma'am.
Okay. So we will see that in the last of the class. Okay. Fine. So here you have to find out the expectation. Okay. So what will be the process? So it will be 0 into 1 by 8 plus 1 into 3 by 8 plus 2 into 3 by 8 plus 3 into 1 by 8, right? Right? Is it correct or not?
Yes.
Yes, ma'am. Is it
Okay.
9
So
by 8, ma'am?
what will be the value?
1.5.
1.5.
1.5. Okay. Yeah, whatever the value is. Okay. So this will be your expectation. Okay. So in this way, we find the expectation of a random variable. Okay. Any doubt?
Yes, ma'am.
No.
So yeah, it would be 1.5. Okay. Or 3 by 2. Okay. Now the next we have to study the Bernoulli random variable. Okay. So anyone knows about the Bernoulli random variable? Any guesses? Or what is a
Ma'am,
Bernoulli trial?
any random variable that takes value 0 and 1.
Yeah, so Bernoulli random variable or Bernoulli trial is a trial that takes only two, like Bernoulli random variable is a variable that takes only two values. Okay. So suppose x is a Bernoulli random variable, so it will take value 0 or 1. Okay. Or we can also call it as success or failure. Okay. Okay. So here we are representing our success as 1 and failure by 0. Okay. Now, if we have to write the PMF of it, so random variable taking value 0 and 1 only. Okay. And the probability of success we represent it by P, right? Okay. So the value of the probability for this, what for 0, how much it will be?
1 minus 2.
1 minus P, right? So from the property of PMF also we can check it. Okay. So sum of these two should be equal to 1, right? So it will be 1 minus P. Okay. Now again, we have to find the expectation. Okay. So expectation of x should be equal to what?
2 times
0
P,
into 1 minus
1
p
minus
plus
P.
1 into p
Hmm.
plus 1 into p.
Right. So it should be equal to P, right?
Yes,
Yes,
ma'am.
ma'am.
So expectation for our Bernoulli random variable is P. Okay, which is the probability of success also. Okay. Next, we have to study the discrete uniform random variable. Okay. Okay, so what is discrete uniform random variable? So suppose x is a random variable which follows this distribution, uniform distribution. Okay, so here it is equally likely to take any of the values. Okay, so suppose it takes value 1, 2 up to n. Okay, so all the values that it is taking are equally likely. So what does equally likely mean?
Probabilities are same.
All have
Any
same
outcomes
probability.
all are having same probabilities of occurrence, right? So if we have n number of outcomes, so what should be the probabilities?
1 by
1 by
n.
n.
1 by n for each, right? So it should be 1 by n for each of the values that x is taking here. Okay. Now this is the PMF for discrete uniform random variable. Now again we have to find the expectation of this random variable. So what should I write?
1 into 1 by
1
n
into 1 by n plus 2 into
plus
1
2
by n
into
plus
1 by n
that n into n by 1 by n.
continues to L into plus.
Right? So I can take 1 by n as common, right? Then it will be 1 plus 2 plus 3 to n, right? Okay, and what is the sum of n numbers?
n into n plus 1 by 2.
1 by 2. It is n into n plus 1 by 2, right? So the
Yes, ma'am.
expectation of x in case of discrete uniform random variable, it will be equal to n plus 1 divided by 2, right?
Yes, ma'am.
Okay. Now we have to study about the expectation of function of random variable. Okay. So any doubt how we find expectation? Any confusion?
No, ma'am. It's
Okay.
No,
okay,
ma'am.
fine.
Now suppose we have a random variable x. Okay. Now we have a function of a random variable x. Okay. Suppose it is gx. So what is function? So suppose we have a random variable x. So it could be x square or x plus 1 or xx plus 1, right? So all these are the function of random variable, right? Okay. So generally I'm representing it by g of x. Okay. So if you have any random, any function of the random variable, and you have to find and you have to find the expectation of this function. Okay, like expectation of gx. Okay, so this should be equal to the summation of this function into the corresponding probability that x is taking value x. Okay, over the range of x. Now let's see example. Okay, so this is the general formula for calculating the expectation for a function of random variable. Okay, so suppose you have a random variable that takes value -1, 0, and 1 with probabilities 0.2, 0.5, and 0.3. Okay, so is this a valid PMF,
Yes, ma'am.
right? Why?
Sum is because the sum of all probability is 1 and every probability is between 0 and 1.
Yeah. Okay, so the properties of the PMF, so both are satisfied here. Okay, so this will be your valid PMF. Okay, now suppose you have a function of variable x, which is x square. Okay, suppose I'm representing it by y. Okay, so this is your function, and for this function you have to find the expected value. Okay, which means you have to find the expectation of y. Okay, so the formula for expectation of y, it will be this, right? Okay, so what is gx? Gx is nothing but the x square. Okay, so what will be the x square? So if I write here, so x square is 1, this is
0,
0,
1.
and this is 1. Okay, So it should be 1 into 0.2 plus 0 into 0.5 plus 1 into 0.3, right? Okay. So these
But
are the values for x
Minus
square.
1 into 0.2.
See, what is gx? So
X
gx
square.
here is x
Okay, ma'am.
square. Okay. So you
Okay,
have
ma'am.
to put the values of x square here.
Okay, ma'am.
we
Okay.
multiply the probabilities we multiply it with the probabilities of
X only.
x only, like.
Yeah.
Okay.
Okay. So we multiply the probabilities of x only.
So,
Okay.
so ma'am,
So this
here
is
we
the
only putting the values of x square and probability of only x.
yeah probability of x, because you know what is this function? This function is made of the random variable x only, right? So you have to take the probabilities for the values that x is taking. Okay, so here, like, what is x square? Here in this case, suppose it is 1. Okay, but x is taking value as -1. Okay, so it is nothing but the -1 square. Okay, so probabilities we have to take for the values that x is taking. Okay, but the function we will be taking whatever is given to us.
Is it possible for you to explain how you getting this formula, expected value of gx?
The proof part, like, I'm not sure about this thing. Okay, that we don't need to understand the proof also, but simply you can understand like this. So we take the function here and the probabilities of x. Okay, like, for the values that x is taking here is small x. Okay, and based on this value, this is the function. Like here in this case, x square is what? 1. Okay, at what point? When x is equal to -1. Okay, so we have to take this probability. Okay, when x is -1, the probability is this, and the function is this. Okay, in this way you can understand it.
Okay.
Okay.
So, ma'am, for E of 4, how did you get that 1 into? I'm still struggling with that. Okay, I understood that x equal to -1, then x square is equal to 1, and for that you're taking the probability. But why did you write 1 into 0.2, then 0 into 0.5? Why for the 4, how is it that it is coming?
So I have written the values of x square.
You have written the values of x square.
Okay, so x square is what? 1, 0, and 1. Okay, so 1 when the probability is 0.2. Okay, then 0. Okay, the probability is 0.5. Okay, then 1 again. This, the probability is 0.3. Okay, so this should be equal to 0.5, right?
That I understood, ma'am. That I understood. My question was how that 4 is related. 4, I'm not able to grasp
No,
that.
it's not. If you are considering this 4, this 4 or any other thing,
Yeah,
this
yeah,
is
that
y,
one.
not this is y. Sorry, not
Oh,
4.
that's
This is
why.
y.
Okay, okay.
Yeah.
I'm sorry. Okay, all right.
Okay, I'm writing it like this. Not 4. This is y. Okay. Now is
Okay.
it clear?
Yeah, yeah, it is clear to me now.
Okay. Now let's take another example. Okay, suppose there are two persons, Sanjay and Anita. Okay, and they work for some company. Okay, and Anita's Diwali bonus is a random variable. Okay, okay, and the expected value for this variable, okay, which is the Diwali bonus for Anita. Okay, so expected value is 15,000. Okay, now our question is that suppose Sanjay's bonus is set to 90% of Anita's. Anita's bonus. Okay. Now you have to find the expected value for Sanjay's bonus. Okay. So how will we do it? There is one more thing. Suppose the expected value you have to find for the random variable ax plus b. So it should be equal to a times expectation of x plus b. Okay. So b and a what? A and b are constant. Okay. Is this clear?
So the Anita can receive bonus in the range, and range is not specified,
So
so
you don't have to worry about the range here. See, so this is the formula you can say that you use here. Okay. Like you can make use of this formula into this question. So what is the question? Anita's Diwali bonus is a random variable. Okay. Now let's suppose that x is a random variable. Okay. What does it represent? Anita's Diwali bonus. Okay. So it represents Anita's Diwali bonus. Okay. And what is given to us? The expected value for this random variable, right? So the expectation of x is given to us, right? Expectation of x is 1500, 15,000. Okay. And what we have to find? We have to find expected value for Sanjay's bonus. Okay. And what we are given, Sanjay's bonus is set to the 90% of Anita's bonus. Okay. So let us suppose that y is another random variable which represents the bonus for Sanjay. Okay. Sanjay's Diwali bonus. Okay. Okay. Now what is given? That the Sanjay's Diwali bonus is 90% to the Anita's Diwali bonus. Okay. Like 90% of x, right? Is this clear?
Yes, ma'am.
Okay.
Yes,
So y
ma'am.
should be equal to the 90% of x. Okay. So y is equal to 0.9x, right? What we have to find now? We have to find the expectation of y now. Okay. So suppose I am taking expectation at both the side of this equation. Okay. So expectation of 0.9 of x. Okay. So it should be 0.9 times the expectation of x. Okay.
Yes, ma'am.
So 0.9 into what is the expectation of x? Expectation of x 15,000. Okay. Okay. So this will be your, this should be the expected value for Sanjay's bonus. Okay. Any doubt?
not a doubt, but this is
1,500.
Where is 500? It is
1,500. Okay, ma'am.
15,000 it is, not 500.
this
E of y is equal to 13,500.
Yeah, it will be 13,500. Okay.
Okay, ma'am. Thank you.
Yeah, what's your doubt?
it is very unintuitive thing. Like we are directly
This,
multiplying it. Yeah, but like formula is there.
okay, see
But
how it works. You have studied about the mean, right?
yes, mean,
Suppose
mean
you are given
and
some, yeah, mean of some variable. So like you have some data set which contains some points. Okay. Then you find mean x bar, right? Okay. Now what we have done, we have multiplied by some constant in each of the values. Suppose it is a. Okay. Now if we have to find the mean, then what will be the new mean? It is a times x bar, right?
yes, yes.
Yes,
Okay.
ma'am.
Okay. So it is nothing but like it came from this thing only.
Okay.
Okay.
And that
So
function,
okay. So the expectation, like if you study about this part only, okay. So initially you will be you were finding the expectation of x, which was like expectation of x. Okay. Now what we have done, we have multiplied a, which is a constant, to the random variable that it is taking some values, and we have multiplied by some constant. Okay. In this case, you have to find out the expected value. Okay. So a times expectation of x. Okay. Like same ideology behind both the things. Okay.
Is linear. Okay, I get it. I can relate it. But like the previous example was a quadratic function. If we apply that thing to the mean, uh, then I'm not getting that one, that quadratic function above x square.
This is different thing. Okay. And this is different. So what's your confusion here?
Like uh this feels very unintuitive to me. Not this one, but actually that one. Like we can do x square, but probability remains same.
Okay, don't worry about that thing, but this is the correct formula. Okay. Okay, now this thing is clear, like how the expectation of ax is equal to a times expectation of x.
Okay, ma'am.
Excuse me, ma'am.
Hmm.
Can you please explain more about this? These constants a and b. Like in this case, is b 0? Like we are not. What is it? A and b. What are these two variables?
A and b not variables. These are some constants.
Sorry. What are these constants? Like in this case, a is 90%, as we took it. That is 0.9.
So here a is 0.9.
And b in this case is 0, right?
Yeah, in this case b will be 0.
Okay, so ma'am, can you please take an example where we'll have value of b also?
B also, yeah. In this case, in the same question also, we have a second sub question. Okay. So in this, Sanjay's bonus is
5,000 more than 90% of.
yeah. So it is the same question from the lectures, if you have seen it. More than Anita's bonus. Okay. So in this case, so y will be equal to x plus 1,000, right? Like this is Anita's bonus. Okay. And 1,000 times 1,000 more than Anita's bonus is equal to the bonus of Sanjay, right?
Yes.
Is it clear? Okay. So the y is equal to x plus 1,000. Now you have to find the expectation of y in this case. Okay. So it will be the expectation of x plus 1,000. Okay. Now if you compare with this formula, okay. So same thing you can use here also. You have some random some variables like some data set, okay, which contains this point, okay, and you have added some constant to each of the point, okay. Now if you have to find the mean or average, okay, so the new mean, suppose the mean is x bar, okay, if you have added some constant, so the new mean will be x bar plus b, right?
Right, ma'am.
Okay,
Yes,
so in the same way we have find out this formula also, so it will be expectation of x plus 1,000, okay, because what you have to do, like you are taking the expectation of any constant, okay, and constant value will always be same because it is not changing, right? Because,
yes.
like all the times it is 1,000 only, okay, so if you take average of it, it will always be 1,000, right?
Yes.
Because there is no
16,000,
variation.
Yes, ma'am.
Okay, so the expectation of constant is always that constant only. Okay,
So the answer
so
is 16,000, ma'am.
yeah, so 15,000 plus 1,000 will be 16,000. Okay, so expectation of y in this case will be 16,000. Now is it clear? Okay, so you can
Yes, ma'am.
compare this formula with the mean, like if you have studied I think it was in week 3 or 4, if we
Yes, ma'am,
multiply
it is in
some constant and add some constant to our data set, how the mean is affected. Okay,
Yes, ma'am.
so
Understood.
expected value is nothing but the average value, like Okay, it gives you the expected value that you can that you will be getting in the long run. Okay, now is it clear?
Yes, ma'am, it's clear.
So
Thank
now
you.
you have to study the expectation of sum of random variables. Okay, now suppose you have two random variables, x and y. Okay, these are two random variables. Okay, and now you have to find the expectation for sum of these two, like expectation of x plus y. So it will be equal to the expectation of x plus expectation of y. Okay. If you want to check this formula, you can use your like you can prove this formula by yourself. Okay, just try to find the expectation of x first. Okay, and then y. Okay, then you try to find the expectation of this random variable x plus y into like this variable only x plus y. Okay, and you will see it is nothing but equal to the expectation of x plus equal to expectation of y. Okay, so you can take example that we have done earlier also. So suppose x is a random variable which is the outcome of your one fair die. Okay, and suppose y is another random variable, okay, which represents the outcome of another fair die. Okay, suppose we have two dice. Okay, and x and y representing the outcomes of both the dice. Okay, now you have another variable which is x plus y. Okay, so expectation of x. So what was the expectation of x? It was, I think, 3.5, right? If you have one die only, then the expected value was 3.5, right? Yes or no?
Yes, ma'am.
Okay. Similarly for y also. So expected value for y also, it will be 3.5, right? Okay. So distribution was like this only, like 1, 2, 3, 4 up to 6. Okay. And the expected, the probabilities was 1 by 6 for each case, right? Okay.
Yes.
And in that case, we calculated the expected value and it was 3.5. Okay. So y is also like same. Okay. So y is for another die. Okay. So y expectation of y will also be 3.5. Now you have to find the expectation of x plus y. Okay. So it should be equal to the expectation of x plus expectation of y. Okay. So it will be 3.5 plus 3.5, which is equal to 7. Okay. Now, if you remember, we solved one question where we taken the random variable as sum of the two dice. Okay. So there we calculated the expectation as 7, right?
Yes, ma'am.
Okay. So now you can verify this formula also. Okay. So here we were taking two dice. Okay. And the random variable was sum of the outcome. Okay. And the expected value, we calculated it as 7. Now you can say that this formula is correct. Okay.
Yes, sir.
Okay. So you can extend this formula for n number of variables also. Okay.
Can I once explain this formula?
Yeah. What's the confusion? Any doubt? Okay, so if you want to extend this formula for n number of variables, so here we were having only two random variables, x and y. Okay, now suppose you have n number of random variables, okay, or any number of random variables you can take. So suppose we have random variables like x1, x2, x1, x2. Okay, so now you have to find the expectation of summation of random variables. Okay, suppose I is going from 1 to k. Okay, so this will be equal to the summation of their individual expectation. Okay, So this is nothing but like expectation of x1 plus x2 up to xk. So you can write it like this: expectation of x1 plus expectation of x2 up to plus expectation of xk. Okay, is this clear? So this is the extension of this formula only. Any doubt?
No, ma'am.
Okay, is it clear now? Now we studied about Bernoulli random variable, uniform discrete random variable, right? Now we have another random variable which is
Excuse me,
hypergeometric
ma'am.
random
Could you
variable.
please scroll up, ma'am?
Hmm.
Excuse me, ma'am. Yeah,
Hmm.
thank you. 1 second.
Done.
Thank you, ma'am. I've come.
So next we have hypergeometric random variable. So all these random variables that you are studying here, like binomial, uniform, and hypergeometric, so you will study these distributions in detail in the upcoming weeks also. Okay. So in hypergeometric, what we have to do, we have a random variable x. Okay. Suppose we have like one box in which n number of objects are there. Okay. And we have two categories. Okay. Like you can suppose that we have balls of two colors. Okay. Suppose this is red color ball and this is blue color balls. Okay. So small m number of red balls are there. Okay. And remaining capital N minus small m balls are blue color. Okay. Now we are taking a random sample. Okay. From this n objects of size small n. Okay. So now what will be the probability? Like out of capital N objects, you are taking small n number of objects, right? And out of m, you are taking suppose small x, and out of capital N minus small n, small m, you will be taking n minus small x. Okay, like from these m, you are selecting small x number of objects. Okay, and out of these, so out of capital N minus small m, you are taking n minus x objects. Okay. So if you take sum of both like x plus n minus x, okay. So your sample size will be equal to n, right? Okay. So you can see that out of capital N objects, you are taking a sample of a small n objects, number of objects. Okay. Some from this category. Okay. And another from this category. Okay. So now you have to take the probabilities. Okay. So which will be this. So let's take an example of it also. Or okay, and the expectation in this case, expectation of x in this case will be n into m divided by capital N. Okay, don't worry about this formula. You will study this like how did expectation came. So the proof
Ma'am,
is in the next week. Yeah.
I didn't get this sample and events. Can you explain what this N, M, and
Yeah.
capital N representing?
Yeah.
I
See.
get confused in that.
Yeah. Okay. So suppose we have an example. Okay, we will study this by example. Okay. So suppose you have like 20 boys, okay, and 10 girls, right? So now in the same manner, I will be framing this also. Okay. So you have 20 boys, like 20 number of objects for one category, right? And 10 girls. Okay. And here we select objects without replacing them. So total we are having 30, right? So our capital N, which is the, like you can say the population size, which is 30. Now is it clear? Okay.
Okay, okay. And
Okay.
what is a small n representing? A
Yeah.
small n and
Yeah.
x?
1 minute, you will get that also. Okay. And that's okay. The question is you have 20 boys and 10 girls. Okay. And you are selecting two students. Okay. Which means you are taking a sample of two, right? Is this clear?
Okay.
Okay. Now suppose you have a random variable x, okay, which represents number of boys chosen.
Okay, got it.
Okay, so this is your first case. Okay. So here x is representing number of boys. Okay. So m will be number of boys in the population. Okay. So your m in this case will be equal to 20. Okay. And n is equal to 2. Okay, which is nothing but the sample size. Okay, because you are selecting 2 without replacing them. Okay. So this is the condition that here we choose the objects without replacement. Okay.
Okay.
Okay, so this is the important thing here. Okay, so n represents the sample size, like you have capital N number of objects, which is 30, total 30 students we have. Okay, and we are taking 2 students, so n will be 2. Okay, and that m depends on like what is your objective. So in this case, x is what? Number of boys. Okay, so m will be equal to 20. And capital N minus m, you can write it as 10. Okay, so capital N is 30, small m is 20, and small n is 2. Okay, now you have another random variable, okay, which represents the number of girls chosen. Okay, so in this case, m will be equal to 10, right? Okay, because we are looking for the number of girls we have chosen in this sample. Okay, so m depends on what is your objective, what you're looking for. Okay, and n, small n and capital N will be the population size and sample size, you can say. Okay.
Okay.
Now you have to find the expectation in both the cases. So here value of m is 10, okay, value of n is 2, and value of capital N is 30. Okay. So the expectation of x in that case, so formula we have studied. Okay. So I think the proof is in the next week when you study about the hypergeometric distribution. Okay. So it is n into m divided by capital N. So n is what? N is 2, right? Which is n. And m is what? M is 20 here. Okay, divided by capital N, which is 30. Okay, so it will be 4 by 3. Right?
Okay.
Now, if you have to find the expectation of y here, so it will be again n into m. So n is 2, small n, then m is 10, then capital N, which is 30. So it will be 2 by 3. Okay. Okay, don't worry about this formula now because you will be studying about the proof also. Okay, so like same procedure you have to follow for calculating the mean for this random variable also. But as of now, just try to remember this formula. Okay, don't worry about like how this m by n came. Okay.
Excuse me, ma'am. Ma'am, so n represents the number of students which we have chosen, right?
Yeah.
Not neither girls nor boys.
No, small n is the number of students. Okay, so in the question we are given that we have to select 2 students. Okay, so small n is equal to 2.
So they
Okay.
can be either from boys or from girls also.
Yeah, so yeah, the students we are selecting can be boy or girl. Okay, so here that's why we have taken the random variable x. Okay, so in this case, x is representing number of boys. Okay, so we will be taking the m as number of boys in the population, which is 20 here. Okay, now in the next case, we are taking number of girls. So m will be number of girls, which is 10. Okay.
Yes, ma'am, I understood.
Now, if you have to find the expectation of x plus y, that would simply be the expectation of x plus expectation of y, right? So it will be 4 by 3 plus 2 by 3, right? Okay. So we can directly find this from the formula, right? Okay. Is it clear?
Yes, ma'am.
Yes, ma'am.
Okay, so till now we have studied about the expectation part, right? How we find the expectation of a random variable and how we find the expectation of a function of a random variable and sum of random variables, right? Now we have to study about the variance. Okay. Like in earlier also, when we studied about the numerical data, we studied about the mean and variance, right? So similarly, here you have to study about the expectation and variance of a random variable. Okay. So what does variance represents? What does it tell you about any variable or about the data set, you can say?
Ma'am, what you ask?
What is variance?
Variance,
Dispersion.
The
dispersion of
variance
data
is
points from the
hmm,
central tendency value.
yeah. So variance tells you about the spread of the data set. Suppose you have a random variable x, which takes value 0 with probability 1. Okay, you have another random variable which takes value -2 into with probability 1 by 2 and 1 by 2. Okay, this is nothing but the probability I have written. Okay, now you have another random variable which takes value, suppose -20 and 20 with same probability 1 by 2. Now, if you try to calculate for expectation of x, expectation of y, and expectation of z, so what it will be? It should be equal to 0, right? Okay. So expectation like -2 into 1 by 2 plus -2 into 1 by 2, right? And in this case, -20 into 1 by 2 plus 20 into 1 by 2. Here it is, sorry, it will be +2 only. Okay. And in this case, 1 into 0, right? So the expectation will always be 0 for these three random variables, right? Okay. But you can see that the values that x, y, z are taking here, okay, so the spread are very different from each other. Expected value is same for both for all the three random variables. Okay, but the random variables, the values that they are taking are not same, right? So here, suppose x is only 0. Okay, next, like it is from -2 to 2. Okay, and in the z, it is -20 to 20. Okay, so you can see that the spread of the variable z is greater than the spread of variable y, right? Okay, like
Yes.
if it is continuous, it will be between these two, or if it is discrete, then it will be taking these two values only. Okay, but the spread is different for all the three variables. Okay, so that's why we study about the variance also. Okay, because expectation alone cannot give you the entire information about the random variable. Okay, now the formula for the variance is, okay, what is the variance formula that you studied in when you studied about the variance for the numerical data set?
Summation of 1 I upon 1 is equal to n xi minus
Summation of
x
xi
bar.
minus x bar का whole square divided by n.
Yes, n minus 1.
Okay, that was different, like sample variance or population variance. Okay, don't worry about that thing. So what it was, like the average of square difference of observations from the average value, right? Okay, so like if you're taking the, suppose we are taking population values only. So it was nothing but the some average of the squared difference, right? Squared difference between what? Observation and their central value, like mean here. So similarly, the formula is variance for the random variable also. So the variance of x, okay. So we represent variance of x like VAR of x or Vx also in short, okay. So variance of x is equal to the expectation of random variable minus mu whole square. Okay, so mu is nothing but the expected value here. Okay, so can you like compare these two things? So here also we are taking the expected value of what? Square difference between the random variable and the expected value. Okay. Any doubt? Do you think this formula is correct, right?
Yes, ma'am.
Now, if you have to solve for this thing, like x minus mu whole square, okay? So it will be x square plus mu square minus 2x mu, right?
Yes, ma'am.
So if you take expectation at
Yes,
both the
ma'am.
sides, so it should be the expectation of x square, right? Plus expectation of mu square. So expectation of mu square will be mu square only, right? Because it will be a constant value. Okay. So we can write expectation of mu square as mu square. Okay. Now 2 mu. Okay. And expectation of x. Like expectation of 2x mu we have. Okay. 2 and mu are constant. Like you can assume that a here is 2 mu. Okay. So it will be 2 mu times expectation of x because x is a random variable. Okay.
Ma'am.
Is it clear now?
Yes.
Ma'am. Yes, ma'am.
Okay. So you can write, so this is nothing but the variance of x. Okay. This is expectation of x square plus mu square minus 2 mu, and expectation of x we have represented it by mu, expected value. Okay. So I can write it as mu again. Okay. So it will be expectation of x square plus mu square minus 2 mu square, right? Any doubt?
So it is expectation of x square minus mu square, which is expectation of x square.
So you can also write it like this, like variance of x is equal to the expectation of x square minus expectation of x whole square. Okay.
Excuse me, one problem this formula solve.
So you did not understand these steps.
No. I have understand this
Madam, how
calculation, but
EFX equals to mu?
acceptance of x square minus acceptance of again x square.
First of all, it is expectation. Okay.
Okay.
Okay. Yeah. Which step?
Madam,
Expectation
EFX equals to mu out there.
This thing.
Yes, ma'am.
See, what I have said that we have represented that expectation of x is what? Expected value, right? Expected value of x. Okay. So here I have represented the expected value of x as mu. Okay, just a notation change. Okay. So expectation of x, I have represented it as mu. Okay.
Okay, ma'am.
Okay. Yeah, that's why expectation of x, I have written it as mu. Okay. So then this step will be 2 mu square, right? Now mu square minus 2 mu square, it will be minus mu square, right?
Yes.
Okay. Any other doubt?
No, ma'am.
No,
Anyone
ma'am.
else? Okay. So variance of x is nothing but the expectation of x square minus mean square, like expected value of x square, you can say. Okay. Now you have to be very clear with this thing that expectation of x square is not equal to expectation of x whole square. Okay, these both are different. Okay, this is what? This is the expectation. Okay, first of all, you have calculated the expected value, then you have taken the square of it. Okay, and this is different. So this is what? Like x square is nothing but the function of x, right? Okay, so you have calculated the expected value of this function of x. Okay, so these both are different from each other. Okay, we will see some example also, then you will see like what is the mathematical difference between the two. Okay, so basically this is your formula. Okay, so let's take a very simple example. Okay, so rolling a die one time that we already have solved. We have calculated the expectation for it already. Now we will calculate the variance for the above examples that we have solved. Okay, so rolling a die once. So the sample space will be 1 to 6, right? Okay, now you are taking X random variable which represents the outcome. Okay, outcome of the experiment. Okay, so what was the probability mass function? Like 1, 2, 3, 4, 5, 6. Okay, and probability of X was 1 by 6 for each case, right? So this thing should be clear to everyone. Any doubt in this case, in this part?
No, ma'am.
Okay, now what we have to do, we will be finding the value of X square also. Okay, so this is X. Now X square will be 1, 4, 9, 16, 25, and 36, right? Okay, now what you have to do, so variance of X we have to find. Our objective is to find this term, variance of X. So for this, we need to find expectation of X, okay, and expectation of X square both. Okay, so expectation of X, how we find it? Simply we have to, like, expectation of X is equal to the summation of X into the corresponding probabilities, right? So expectation of X, we have already calculated it. Okay, so it is 1 into 1 by 6 plus 2 into 1 by 6. Okay, up to 6 into 1 by 6, right? So expectation of X, the value of it was 3.5, right? This thing we have already calculated, expectation of X part, right? Any doubt in this thing?
No, ma'am.
Okay, now what we have to do, we have to find the expectation of X square. Okay, so X square is nothing but the function of X. Okay, so simply you have to find that X square into probability of X. Okay, so X square is what? 1. Okay, then corresponding probability is 1 by 6. Okay, so 1 into 1 by 6 plus 4 into 1 by 6 plus 9 into 1 by 6. Okay, plus 16 into 1 by 6 plus 25 into 1 by 6 plus 36 into 1 by 6. Okay, so this will be your expectation of X square. Now solve this thing.
Is it 14.5, ma'am?
15, madam. 15. 15 plus E of X square 15.
It will come around 15.16. Okay. Okay, try to solve it. It will be this, I think. Okay. Now we have to find the variance of X. Okay, so variance of X is equal to expectation of X square minus expectation of X whole square. Okay, so expectation of X square is 15.167 minus expectation of X is 3.5. Okay, so 3.5 and whole square. Okay, so this step is clear.
Excellent.
Okay, so the variance of X will be equal to okay, try to solve it. So this thing you have to find, this will be the variance of X. Okay, you can do it. Okay, now in the same way you can find
1.917, ma'am.
okay, whatever the value is, I'm not worrying about the value, okay? But you should know how to calculate it, okay? So the procedure is clear to you,
Yes, ma'am.
okay? So in this way, you can find the variance, okay? Now, if you have to find the variance, like suppose you have another experiment, okay, that we have seen earlier also, like rolling of two dice, okay, rolling of two dice. So again, the random variable we are taking as the sum of outcomes, okay. So now again, you have to write the PMF first. So sum will be like this, 2 to 12, right? Then you will be finding out the x square value, okay. Okay, so in this way, you will find x square, okay, and then corresponding probabilities you have to write, okay, which was, I think, 1 by 36, and in this way, okay. So now next, for finding out the variance, okay, first of all, you have to find the expectation of x square and expectation of x, okay, and same procedure you have to follow, okay, and you will be getting the values of variance of x. Any doubt?
No, ma'am.
Okay. Similarly, you can do it for the tossing of three coins also. Okay. So the sample space was like this, something. Okay. So in this way, first of all, you will find the sample space. Okay. And x was the number of hits. Okay. So it was 0, 1, 2, 3. Then you will find x square. Okay. 0, 1, 4, and 9. Okay. Then probabilities. Okay. So both the things, expectation of x square and expectation of x, you have to find. Then you have to put the values in the formula and you will get the value of variance of x. Okay. Now let's find out the variance for the Bernoulli random variable that we studied and the uniform random variable also. Okay. So that are the very famous distributions. You will study in detail also. And try to remember the formula of expectation and variance for Bernoulli and other distributions also. Okay, so expectation we have already find out. So Bernoulli random variable was like this, 0 and 1. Okay, 1 with probability P, probability of success was P. Okay, so we are denoting success as 1 and failure as 0. Okay, so this will be 1 minus P. So expectation was P, right? In this way we calculated it. Okay, now we have to find the expectation of x square. Okay, so x square will be 0 and 1 only. So expectation of x square will also be P, right?
Yes, ma'am.
Okay, so like 0 square, like 0 square into 1 minus P plus 1 square into 1 square into P. So it will be equal to P only. Now you have to find the variance of x. Okay, so expectation of x square minus expectation of x whole square. Okay, so it will be equal to P minus P whole square, right? So it will be P. If I take P as common, then it will be P into 1 minus P, right? So this is the formula for variance of x in Bernoulli random variable. Okay. Now similarly, we will find for the uniform discrete random variable also. Okay. So this uniform distribution is for discrete case. Okay. So x was taking values like this, 1, 2, 3 up to n, right? Okay. Then the probability of x was 1 by n for each case, right? Okay. And we calculated the expected value, which was n plus 1 divided by 2, right? Okay, if you remember, this was the expected value for x. Okay, now you have to find the expectation of x square. Okay, so this will be 1 square into 1 by n plus 2 square into 1 by n plus 3 square into 1 by n. Okay, up to n square into 1 by n. Okay, now let's suppose 1 by n is common. Okay, so it will be 1 square plus 2 square plus 3 square up to n square. Okay, so it is the summation of n square, like square of positive integers and positive integers. Okay, so it is nothing but n plus 1 to n plus 1, right? Divided by 6, right?
Yes, ma'am.
Okay, so expectation of x square will be equal to n plus 1 into 2n plus 1 divided by 6. Okay, now we have to find the variance of x. Okay, so variance of x will be n plus 1 to n plus 1 divided by 6 minus n plus 1 whole square divided by 2. Okay, now you can solve this part, right? You can do this, right? Or no? Simply you have to subtract this term from this. Okay, so the variance of a, this will be equal to n square minus 1 divided by 12. Okay, you just have to solve this. Just take LCM. Okay, and simply so the variance will come out as n square minus 1 by 12. Any doubt?
No, ma'am. It's clear, ma'am.
Anyone else?
मैम LCM 6 होगा. Why 12?
Sorry?
Ma'am, LCM 12. How?
It would be
I,
6.
ma'am, there should be 4 in place of 2 in n plus 1 square by 2.
Yeah, sorry. It will be n plus 1 divided by 2 whole square. Yeah. Or you can simply write 4. Okay. Yeah, you just solve it by yourself. Okay. Yeah, it will be, you have to take LCM
Can
for
you
6.
please just scroll the ma'am? Yes, okay.
Okay. Okay, so we studied this thing like expectation.
Ma'am, this PDF uploaded, no?
Not yet uploaded. I mean, it will be uploaded.
Okay.
Okay. So for expectation, you studied this thing, right? So the formula works like this. Okay, so the similar thing you have to study for the variance also. Okay. So suppose C is any constant. C is any constant. So the variance of C times of X. So can you tell me what should it be?
C square variance X.
C square times variance of X.
Yes, ma'am.
Okay. So like go back into that numerical variables variance when you have some data points. Okay. And we multiply by some constant. Okay. And we try to find the variance of new data set. Okay. So it becomes constant square times the old variance, right? Is this thing clear? Okay. So
Yes.
variance of C times of X will be C square times variance of X. Okay. Now, if you are adding something, adding a constant into the variable, okay. So suppose variance of X plus B. So if you have variance of X plus B, then what it should be?
Variance of X.
Variance of X only,
Yes, ma'am.
right? Because if we add something to the data points, okay, the variance does not change, right? Spread becomes this remains the same. Okay. So the variance of X plus B will also be equal to the variance of X only. Okay. Now, if you try to combine both the formulas, like variance of CX plus B or AX plus B, you can take. So it will be c square times variance of x, right? Any doubt?
No, ma'am.
Okay. Now, if you have to find the variance of sum of independent random variables, okay. So suppose you have random variables x and y, okay, and you have to find the variance of x plus y, okay, and here like x and y should be independent, okay. So if x and y are independent, okay, then variance of x plus y will be equal to the variance of x plus variance of y, okay. But remember this thing, this formula is valid when x and y are independent, okay, then only this formula.
Ma'am, this two random variable association, I think, is this in stats 1?
Association.
It's stats 2, I think.
What topic?
This independent random variables.
In the stats 2 also you will be studying the independent random variables, but here also you have things like that.
Which week it is covered?
Week 10.
You are asking for independent random variables.
Yes, like two random variable being independent.
So if you have studied the probability part, then you should know what are the independent variables, independent events, you can say.
Yeah, independent events. But like two random variable independence is checked from the PMF table.
Yeah, from PMF table also we study that thing is in the stats 2 course.
Yes,
Like when
that's
the
why I think
PMF
that
of x comma y is equal to PMF of x into PMF of y.
y for every x and y throughout the table.
Yeah. Yeah, this
But
thing is in stats 2.
yeah, that's why I thought that this topic is not in stats 1, I
Don't
think.
worry about that because if two variables dependent, it will be mentioned in the question. Okay. So then only you can apply this formula. If they're
Okay.
not independent, then variance will not be this only. Then some covariance part also comes in that formula. Okay.
Okay.
Yeah. So like if you have to find like variance of x plus y. So first of all, you need to find out the variance of x individually, then then variance of y. Okay. Then just add these two and you will be getting the variance of x plus y random variable. Okay.
So it will be mentioned in question that these two variables are
Yeah,
independent.
it will be
We
mentioned in
don't
the
need to
question.
check that.
Yeah, it will be given.
Okay.
Okay. Next thing, we should study the standard deviation, right? So standard deviation also you should know. What is standard deviation?
The root of variance.
Yeah. So standard deviation is nothing but the square root of positive square root of variance. Okay. So standard deviation of x is square root of variance of x. Okay. Now, if you have to find the standard deviation, so what should be? If you don't
Mod
remember
of C.
this formula for
Mod of C into root of var x.
so it is c times standard deviation. Sorry, yeah, c times standard deviation of x.
Yes, ma'am.
Okay, so simply it came from this formula only.
This should be absolute value of C. Like if even if C is negative, then we get outside positive.
Yeah, it will be positive only.
Okay.
Okay,
ABS.
because suppose you have like variance of Cx. So it is nothing but the C square times variance of x. Okay, now take square root of both sides. Okay, so it is standard deviation of x. Okay, and it will be C. So it will be positive square root. Okay, so it will be positive always. Okay, then square root of variance of x, it is standard deviation of x. Okay. So similarly, you can find it for like standard deviation of x plus b also. Okay, so what it should be? Standard deviation of x only, right? Same thing you can derive for the from variance formula, right? Because if you add something, it will not affect your variance as well as standard deviation, right? Okay. Any doubt? Like suppose you have variance of x is equal to 4. Okay, and you have to find the standard deviation of 3x. How will you find?
And 6.
6.
Yeah. So standard deviation of 3x should be 3 times standard deviation of x, right? And standard deviation is what? The square root of variance of x. Okay. So which is 3 into square root of 4. Okay. So 3 into 2, which is equal to 6.
6. Okay.
Right? Similarly, like variance of 2x plus 3 also. Okay, suppose it is 16. Okay, and you have to find the standard deviation of x only.
Is this x inside the variance and standard deviation same?
Sorry?
Like you used a lowercase x and uppercase x, two different positions, and whereof 2x plus 3 and SD of x.
Ma'am.
In this last line you wrote.
So variance
This.
of 2x plus 3, it is given you as 16. These two are different questions. Okay? They are not same.
Ma'am, is the also 2?
Okay, so the variance of 2x plus 3 is given to you. Okay, so you can write this term as this also, like 2 square into variance of x. Okay, so this should be equal to 16, right? This thing is clear?
Okay.
Yes, ma'am.
It out? Okay,
No.
so 2 square, okay, times variance of x, okay, and 3 will not affect the variance, okay. So 2 square times variance of x is equal to 16. So variance of x will be equal to 16 divided by 4, right? So variance of x will be 4. So the standard deviation of x will be equal to square root of 4, which is 2. Okay. So these were the topics in week 10. Okay. So if you want to ask anything, you can ask. Any doubt?
Once
Ma'am, I
explain
have
last 2 square
I
into
have
variable.
doubt from week 9.
Okay, I'll tell you that also. Yeah, from week 10 first. From this part, any doubt?
When last 2 square into variable of x.
See what I have said here, like variance of 3 of x. Okay. So this was 3 square times variance of x, right? So if you are given variance
understood.
of 2 of x, so it will be
Just
2
by
square times variance of x. Now clear? Clear?
variable of cx plus b equals to c square into variable of x.
Yeah, you can use this thing also. Okay.
Okay. Okay. Thank you.
Okay.
Ma'am, I have doubt in activity 10.5 question third.
Okay, see, week 10 doubt session will be there. Okay, so you can ask the questions in the doubt session. Okay, because we have like it's about to be 8. Okay, so I will not discuss the activity questions now. Okay, now you can ask that question from week 9.
Yes, ma'am. So it was saying that area under the curve of CDF is equal to 1, and that option is wrong. So is it any fixed area under the CDF? Like under the PDF area is 1.
What is the like? Where is the question?
I think 9.6 question 1.
Okay.
Point.
9.6.
Yeah, 9.6 question 1.
Yeah, so it is given that which of the following statements are wrong about the cumulative distribution function for a discrete random variable. Okay. Yeah, so now what's your doubt?
Last option. So this is area under the graph of CDF is always 1. And this option is wrong. I checked the answers and this option is wrong. I mean, we have to select wrong options and this is the only one we need to select. So why this option is
So,
wrong?
see, so here the random variable given to you is discrete. Okay. And when you have a discrete random variable, okay, 1 minute. So when you have discrete random variable, okay, so the graph of CDF becomes something like this, right? Hello.
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Okay.
My
So in
turned off.
discrete random variable, we do not say about the area under the curve. Okay, so area under the graph of curve is always 1. This is true for continuous random variable. Okay, but we have discrete random variable. So can you say the like area, because like it is open. Okay, there is no closed curve.
But we can make like rectangular sections, then
No, but in that case it will not be 1.
it won't be 1.
No, actually we don't talk about area in case of discrete random variable.
Okay.
Okay, like you have this is the graph for CDF. So how can you find the area in this case? Right?
Okay.
That's why it is wrong.
And there in week 9 lectures, there was ma'am was talking about something that e raised to x, a kind of something formula. I didn't get it. Lecture for 18 minutes. Just a second, ma'am. I sent the screenshot of that. Till then, you take some other note.
Okay. Yeah, any other question? Any other doubt?
Bye. అయిపోయిందా ఇది మాకు చెప్పు ప్రోగ్రామ్ రా ప్రోగ్రామ్ చెప్పు అంటున్నా అన్ని చెప్పు స్టార్టింగ్ నుంచి
Please mute your mic if you don't have
స్టార్టింగ్
to
తప్ప
ask any
అన్ని చెప్పు
question.
13 చెప్పు 13 కాదు అన్ని ఫెబ్నోకి అరే నిజంగా రా
Yeah, any other question? Any doubt? Else we can end the meet.
Just a second, ma'am. I'm pasting this. Yes, ma'am. So what is this? Is this formula at the end? C e raised to lambda. I didn't get it when she
So
is
this is the
explaining.
extension for e to the power lambda.
But how? Where it is used and how?
Like in the calculation part, you can see you are getting the values sum of lambda to the power I divided by I factorial. Okay. So have you studied the expansion formulas in your class 11th or 12th?
No, like I
And
was
So there are
from.
some expansions, okay, like e to the power x, sin x, cos x also. So this is one of them, one of the expansion. Okay, so e to the power x is equal to this summation. Okay, so if you have like e to the power x or e to the power y, e to the power lambda, whatever the variable is, okay. So suppose if you have e to the power lambda, okay, if you write the expansion of this, it will be 1 plus lambda
1 plus
divided by 1
x by
factorial
1
plus,
factorial plus x square by 2 factorial plus so on and so on.
yeah, in that way only 1 plus x square divided by 2 factorial plus x cube by divided by 3 factorial in this way. Okay, so there we were like we were having that step, so that's why we have written that expansion into e to the power x or e to the power lambda. Okay, so this is the expansion that we have used.
Okay, and one more thing, like I have some problem in this combinatorials. Like I posted on the Discord and I mentioned you, but nobody answered there. Can you check it?
Sorry, which question?
This I pasted the Discord link here. So like whenever we have question like this, there are 5 black ball, 4 white ball, and what is the probability of picking 2 black ball without replacement? So should I do 5c2 by 9c2 or 5 by 9 times 4 by 8?
See, you can use any of the method. I think both will give you the same result, right?
Yeah, actually it was giving, but like it
Okay,
confuses me.
what was the exact question?
Huh?
What was the question?
That there are 5 black balls and 4 white balls. What is the probability of randomly picking 2 black balls without replacement?
So without replacement, you have to select 2 balls. So like if you are selecting 1 ball, okay, so it will be 5 by 9. Okay.
Yes.
And then for second ball, it will be 4 divided by 9.
Okay.
Okay.
Yes. So, we can use combinations also, like 5C2 by 9C2. Both are valid. Is it true? Um,
Like in combination also, you are selecting two things. Okay, and that is also without replacement because uh, like when we study about the combination, all the objects are distinct, so we don't repeat them. Okay, so if you are selecting two objects, so that will always be different, which means it do not select one object two times, right? So that's why both the formulas will give you the same result.
Okay. And
Okay.
one more thing, then what we exactly do in Bayes theorem, like I studied it, but I got confused I confused again when I saw it in exam, and I think I did it wrong also there.
Okay, I'm explaining you in the short because we have time limit also.
Yes, yes, yes.
So Bayes
Just one
theorem,
example if you have.
like Bayes theorem is like you can say the extended version of the conditional probability, right?
Okay.
Okay. So in conditional probability, what we do, like one event has already occurred and you have to find the probability. Given that, like you have to find the probability of another event, given that something already happened.
Yes, ma'am.
So like this is the extended version of this. Like you will be giving some scenarios. You have like red balls, white balls. You have taken one thing. Like sorry, I'm not able to remember the exact example of this, but
Yeah. So like I have that example here. So we have two black ball and 8 white ball in bag one, six black ball and 4 white ball in bag two. Now, given that black ball is selected, what is the probability that it was selected from bag one? So how should I solve it? I actually get confused and should I multiply it by half
yeah,
also after
actually,
getting.
Bayes theorem questions confuses. Okay, but only thing is like if you solve more and more questions, you will find the pattern, like how you solve this question, how you have to identify like it is A given B or B given A. Okay, so like most of the people get confused in this thing only, like whether like in English you will be giving the probabilities and you have to find out like whether it is probability of A given B or B given A, something like this, right? So
Ma'am, can you
practice more and more questions, okay?
yes.
And you will get like how like formula works.
Yes. One last thing, ma'am, can you just solve this one? Like, I didn't get whether I'm doing it wrong or right. So two black ball from bag one
Okay,
and
I will
8.
discuss in the next, okay, because I also have some other tasks. Okay,
Oh, okay,
already
okay,
it's
ma'am.
8. Okay, so we will have some another session and we will discuss these questions also. Okay.
Okay, ma'am. Yeah, week 8 was very confusing, so please
Okay,
okay.
okay, fine.
Excuse me, ma'am.
Hmm.
Ma'am, do we have any other group for discussion, official IITM group, or the Google chat or Google groups is the only thing for discussions?
Yeah, I think this is the only thing. I don't think there is any WhatsApp group or something.
No, not WhatsApp group, ma'am. Other officially recognized groups from IIT, hosted by IIT itself.
It's discourse only.
But I think only members with mail ID provided by IITM can log into it, isn't it?
Not sure about these things.
Okay, ma'am.
Okay, any other doubt or we can end the session now? Okay, then thank you all for joining.
Thank you, ma'am.